Hi YouTube, AC Dodd here again, and welcome to part 4 of how it works. And this time we're going to go straight on to carb dampers and oils. Okay, so we've obviously already gone through 3 parts of this video discussing how the carburetor works so far. We've talked about airflow, we've talked about springs, we've talked about the needles, and now we need to talk about the dampers and oils. So the reason why we need to do that is because the damper affecting the carburettor, and what I'm talking about here is the damper itself is the piston, and obviously, as you can see, what's dripping off the end there is the oil. And that combination forms the damping effect that we get on the piston. So I've removed the needle at the moment just to make it easier to handle. But effectively, the damping effect is how fast that goes up and how fast that goes down. And what does that actually mean? Well, effectively, when you put your foot down in the on the carburetor and open the throttle valve, you communicate engine vacuum to the ports underneath. You also allow, as that piston starts to rise, you allow airflow under there. Now, if there was no oil in there, what would happen? I'll simulate that. As soon as you put your foot down, that would run straight up to the top, or very near to the top. Okay, and the problem with that is the engine will then gasp because it will receive too much air, and the air fuel mixture will go lean. Okay, so what we need to have is a damping effect. And the reason why we need a damping effect is, as you put your foot down, it's impossible to push this up fast. And what that does is gives us what I've alluded to before, is the variable depression effect. Because if that won't lift and the airflow rushes in underneath the piston, what you're going to get with that high speed airflow over that jet is the demand is high and this piston won't open up fast enough. So that increases the depression over the jet, which pulls off more fuel for a given jet size that we've happened to be exposing to the airflow at that particular point. Now, obviously, we've already discussed that the jet itself is a variable jet design. So in actual fact, what we've got here is a variable jet and variable depression. Any dynamic movement, throttle opening or throttle movement, if you push the throttle down and open it, you come up against the damper effect, which momentarily increases the depression over the jet, which gives you enrichment on acceleration. Okay, so it sounds quite complicated, but it's actually needed. All right, because the problem with with fueling an engine is at any steady state speed, you need the needle profile to give you the mixture that the engine needs at that point. So if you're cruising at high speed, the piston sits up a little bit further, but it's not moving. Okay, and if you're cruising at low speed, the piston's down a bit further. Okay, because it's there's reduced airflow, but it still needs to meter off the correct amount of fuel. And it's doing that because it's lifting the needle at the same time the piston is rising, and it's presenting a certain amount of surface area. So when you go faster, there is a little bit more airspeed that pushes the piston up, which obviously lifts the needle out, which then increases the jet area. The problem comes is the moment you push the throttle. The moment you push the throttle, this will fly up out of the way, as I've already mentioned. So what you need to do is to choose a rate of damping effect that gives you the localized increase in fueling you need to cover that dynamic movement. Okay, and that's what the damper does. So, yep, I know we're talking about oils and dampers, but here's a needle. Now, the reason why I'm showing you this is because the damper, the needle and the oil have a symbiotic relationship, because the oil and damper responds to the fueling that's being provided by a given needle size. Okay, so that's why when you set your carburetor up, firstly you have to do it in order. So firstly you set the spring, then you set the needle to give you a steady state fueling at all points. Okay, and then you choose the oil and damper that gives you the effects you need and the enrichment you need on acceleration. That's only for obviously driving and power. Okay, the damper also has the effect of, when you close the throttle, the piston needs to drop. Okay, and on some carburetors it might drop very slowly like that. On other carbs like this one, it'll drop reasonably quickly. And the reason why you need to control both rise and fall is quite simple. We've already covered the rise, and that is to do with the enrichment on acceleration, or as you move the throttle. And the second issue is when you close the throttle, you want that piston to fall into the right place, so when you go for another gear, there's going to be no flat spot. Now, there is another reason as well. On some engines, you might find, for example, if you fit a carburetor designed for a smaller engine on a larger engine, that actually closing that piston can mean a very rich fuel mixture on overrun. And that's where you would perhaps choose a damper to keep the piston open, and then that allows air to flow over the jet. But at such, because it's such a small demand because the throttle's closed, it's slow enough over the jet that it doesn't pull off any additional fuel and effectively leans out the fuel mix. So that's why you might want a slower drop damper. So what damper do I need? Well, there are lots of different dampers. But typically the one in the middle there is the 8103, which is AUC 8103, which is the typical damper that's fitted in a classic Mini, for example, HS4. Over here we have the 8114, which is, you'll notice, has got a lot more lost motion on. Okay, so when we just compare that, you see that one there moves a little amount, that one there moves a lot more, and that's the amount of initial movement the piston will give in the carburettor before the damping effect takes place. And what that does is have the effect of starting the enrichment sooner in the cycle. So typically you use that damper in twin carb applications where you may want to reduce the sensitivity of the needle and jet assembly at low throttle openings. It's very useful and can be used in single carb applications as well, particularly maybe larger engines. They would definitely benefit from that. The problem with dampers though, and oils, is tolerances. Okay, so these are all used dampers, and as you can see, there's quite a bit of wear. That affects the way that piston operates, and that's why there's no fixed hard and fast rule about what part numbers that you have. Sometimes, as in the case of this damper, now this is a damper that you can't buy. This is a damper that I often have to make up when I'm working on HS4s and tuning on the road. So this is an 8103 cap, and then it's got the shaft and the end from an LZX 2085 from a HI 44. And the reason why we might want that is because this diameter here is larger than these ones, so it makes my piston rise much slower, and it also gives me at the same time a much faster drop, so I can control both the up and down movement of the piston by selecting the appropriate damper. Okay, so what I'll attempt to do here is give you a demonstration of what I mean. Okay, so in this first example, we've got ATF oil in the dashpot, and I've got the original 8103 damper. So let's just have a look at the rise, okay, and the fall. You can see that actually rises quite easily and drops quite fast. And that won't suit any particular combination. because I know a lot of you take things very literally when you see stuff. You think, oh, that's a fast rise and a fast drop, that must be good for performance. Don't assume anything. What that's good for is an engine that needs that type of arrangement, and you'll only know that by measurement. So what I'm going to do here now is I'm going to change that for my hybrid one, which is the 2085 from the HI 44. So what we're going to do now is same oil, and now we'll see what happens. Okay, so you can see that drops very fast, but that's much slower rising. So I'm putting about the same pressure on that. Okay, and what that will do is that takes much longer to rise. Okay, so that will increase the fueling on acceleration. Now, the interesting thing about changing dampers and oils, because at the moment I haven't changed the oil, that's the same oil, it's just a different damper, is we can also have detrimental effects. So what I'm going to do now is change this for 2050 oil. So here we are, we have our carburettor, and we've now got 2050 oil in with the hybrid damper. So let's have a look at the rate now. So if we start to rise that piston, look how slow that now is. The drop rate, so the drop rate's slow, or slower than the previous one, but the point is that it's now very slow going up. It takes absolutely ages and much faster coming down. So my point is, dampers have to be selected, and oil has to be selected to work together. So you can't just, you know, expect the damper that you've got fitted in your carb to do what you want for your application. Now, in terms of what this might look like for an application that's detrimental, the problem with the SU is acceleration. So if you've got a very light vehicle and you're in a low gear and you put your foot down, say like in first gear with a very light car, the engine will need to accelerate very fast up to its highest RPM for maximum performance. So if you do that in this application, when you open the throttle, that car or that carburettor is actually not going to open up anywhere near as fast as that engine can go from 0 to 6,000 RPM, accelerating the car in first gear. So the problem is if you need oil and a damper that thick to get the enrichment you need, you're actually going to slow the car down, because that's going to hold the engine back during acceleration. So when you get an application where your acceleration rate exceeds can exceed the rate at which that piston rises, that's an application where you perhaps need a bigger carb or two carburettors as a twin carb application. So the idea there is the bigger carb for a given piston rise can actually present more airflow to the engine. So that's where a twin carb application would work perfectly for you. In this particular case, this wouldn't work well unless it was a heavy vehicle, or maybe an engine that's got a very large engine on a small carb and you need a lot of fuel, and perhaps it's pulling a heavy weight, heavy car, and then that might be an application that might work in. Okay, so if we come back to dampers, and in particular, if we look at the end here, which is the business part of what goes on. So this collar on the outside is responsible for the piston rise rate. So the diameter of this collar, the larger that collar is, the slower the piston rise will rise for a given rate of oil. This part here is responsible for the drop rate. So the smaller that diameter is, and the more shaped like this one is, the faster the oil will transfer up the middle and round the outside of that, which will allow the piston to drop quicker. So it is possible for any particular given damper to modify these components. And those of you who've watched my on the road tuning, you would have seen me typically modifying these components. So filing a flat on that outer collar, for example, will allow more oil to go past for a given viscosity. That means effectively reducing its diameter, which will increase the speed at which the piston will rise, which will have the effect of leaning out, the accelerator pump effect. And reducing the diameter of this collar would have the effect of making the piston drop faster. Okay, so that's a couple of common modifications that you see me doing, and other people that I've trained will use these modifications as well in order to get an engine to perform the way that it needs to, or to get the best out of it. The other thing is, on some applications it is actually needed to make custom versions of these to actually give you the appropriate rise rates that you might need, such as twin carb applications, or applications that need a specifically a slower rise, or perhaps you're compensating for wear inside the piston tube. And the piston tube, which is found in the piston of the carburettor, which is this. That is the piston tube where the damper goes in, and obviously that will wear over time, and once that wears, the distance from the collar to the inside diameter of the bore gets bigger, and for a given grade of oil the damping effect reduces and the piston rises faster. The other thing that affects the rise and fall rate of the piston is the fit of that piston tube inside that bearing. Now, on the HS type carburetors, these are a plain bearing, as you can see there, and therefore they are machined to a tight fit. Now, oil grade will have an effect. So the thicker the oil that's in there and on the outside of that tube, the more friction and the slower that will move. Okay, so later carburetors, the HIF for example, have a different arrangement. HIFs use a ball bearing, and what you can see there just inside that hole is the ball bearing collar, and what that basically produces is a nice free running fit, and the only contact is the point contact given by those ball bearings on the outside of that piston. So effectively what happens here is when you change the oil for a thicker grade, it has minimal effect or no effect on the friction. So irrespective of what oil you put in there, the drop rate is unaffected by the fit. The only effect that will affect the drop rate is obviously back to the piston and the damper rod fitted inside there. So these are preferred for more performance applications. However, the latest SUs, including my own, don't use that. They've gone back to this type because of production costs. So you can't actually buy an HIF SU now with a ball bearing suction chamber, so they're all the plain bearing type. But the good news is, on my zero tolerance versions, I've come up with a modification to reduce the friction and actually make the plain bearing dash pots to be more independent of the oil grade used. Okay, oil grades. This one's quite straightforward. These are the oil grades I carry with me. So we've got Jack oil, we've got 1040, we've got 530, we've got 2050, and we've got ATF, which is of course automatic transmission fluid. So the question I always get asked, and I'll say it here and I'll say it probably not for the last time, there is no one grade that suits every application. That's why it's called tuning. You have to find out which grade of oil your particular application needs. So these are the ones I use. Now, you'll notice there's some multi-grades there. Multi-grades can be beneficial because, for example, the 2050, for example, it's the same as a 20 weight oil when it's at in the winter temperatures, and then obviously it thickens up, so it's the same as a 50 weight oil when things are hot. So all you have to remember is different oils give different effects. So the important thing to understand here is use the oil that works for you. You'll notice I don't have SU oil here. SU oil is 20 weight single grade oil. There's nothing wrong with the SU 20 weight oil. The only problem is it doesn't suit every application. So these are the ones I carry. I've been discussing with SU about offering a range of different oils, and perhaps that will happen in the future. But for now, all I'll say to people is use whatever oil gives you the damping effect that you need for your car. Simple as that. Okay, so back to me. Hopefully that little series has helped you understand a little bit more about how the SU works. And, you know, the idea here is to give you a little bit more understanding so that you can make more educated decisions yourselves. The only thing that's disappointed me about this series is the viewers have been down on YouTube. Now I'm just assuming because it's boring, and that's fine, and I'll get that. But the worrying thing is the views go down on a video. This video is actually being provided to make it easier for them to understand about what they need to do to make their carburetor perform properly. So if people aren't watching this, they're doing themselves a disservice, really, because they're not going to understand and they're not going to be able to get the best out of their cars. All right, so please share this video and let people understand that there is more to the SU than perhaps people first thought. Anyway, if anybody wants to learn more, I obviously offer training courses. So I do a 2-day course on how to set up engines, which includes ignition, timing, going through the ignition components, also obviously how to set up the carburetor, and more importantly how to modify needleless dampers and all that kind of good stuff to get the fuel in where you need it. It's not cheap, 2-day course, but it's designed for those in the trade that want to learn a bit more about it and perhaps can bolster their business. So if anybody out there is interested in training, then please get hold of me by sending me a message on Facebook Messenger to discuss your requirements. I also offer another course on modifying distributors. Again, for those that are in the trade or perhaps are interested in being able to modify their own distributors or even start a business modifying distributors, then please get in contact. Anyway, for the rest of you out there, hopefully you found this video useful. As ever, please like, subscribe, and I'll see you soon. Thank you very much.